we need to have an immutable architecture. Once you have deployed your servers or VMs or containers, you don't have to make changes to the system. In the immutable architecture, you have all these machines and they have like the same configuration, same image. With that, you have scalability, reproducibility, resilience, integrity of the data. So all these things come into play.
So welcome to our channel. I am Saad Arshad. So today we'll talk about protecting sensitive data with a security first approach with Tayyab. So Tayyab, thanks a lot for joining us. Tayyab has 13 plus years of experience leading and mentoring software development teams of various sizes and experiences. He has been leading technology development for Fortune 500 companies and has experience managing large scale enterprise grade projects for different industries: e-commerce, B2B, B2C, supply chain, point of sales, BI solutions, and social media platforms. And currently, Tayyab is our Director of Engineering at Xgrid. So, Tayyab, thanks a lot for coming. So, Tayyab, let's just get started. So, we hear a lot about PII. Mm-hmm. So, first of all, let's just define PII. Can you explain what is the importance of PII for maybe from a CISO?
Yep. First of all, thanks for having me. It's a pleasure to be here. PII is very important for any organization. So it involves protecting information on different levels. For example, when we are collecting the personally identifiable information, when we are making use of that information, when we are storing that information, where it actually resides. And it further extends to the infrastructure where it is hosted or the infrastructure that holds that data. The infrastructure that can be your servers, your network, your public cloud, whatever that makes up your IT infrastructure, that needs to be secure. If it is not secure, then certainly your PII data is at risk. And why it should be the top priority? Because it is so important that it is for the survival of your organization. So you have to protect your sensitive information from malicious outsiders and careless insiders. So when I say malicious outsiders, you have to think of cyber criminals who are quite advanced in their research, and every now and then new attacks are being launched. So they are quite advanced. As far as the careless insiders are concerned, obviously you have the employees, you have your customers using your data. They can actually expose your system. They can expose your data. So you have to make sure that on all the stages, your data, your sensitive information remains secure. And then when we talk about the PII itself, it is any artifact that we can use to trace back to the owner. It can be a credit card number, any social security number, bank information, any trade secret, any business contracts. So we have to design the system in such a way that it handles this sensitive information, and therefore it has become a requirement for these organizations who are actually processing this data, who are taking care of this data, storing this data, to comply with certain data protection legislation such as GDPR, HIPAA, or PCI DSS. So this is to ensure they have, or they can preserve their competitive advantage.
Okay, so you tell me, what's the difference between compliance and security?
Yeah, this is the term that normally misunderstood, and people think that, and the organizations think that compliance is one way or another the same thing as security. But compliance, on the other hand, is these are the laws that any governing body can use to levy fines. So you have to obviously be compliant, as I mentioned, the GDPR or HIPAA or PCI DSS. So if any specific industry requires you to comply with those standards, you have to abide by those standards, and you have to think that and may take considerable measures to make yourself compliant. But this is not security. So you have to have a security first approach to mitigate any risks, any attacks. So that can be a baseline for the compliance, but in its entirety, it's not any compliance. And on the other hand, when we talk about the compliance, we know that there can be certain situations where we are securing the PII. Okay, for example, we have acquired or collected a PII, and we are keeping it secure. We have encrypted it. We are storing it in such a way that no one can bypass the system, and we have certain monitoring over there that overlaps. So all those practices have been keeping the data secure. But imagine yourself that you haven't taken consent while taking this PII. Your PII is obviously secure, but you're not compliant because you have violated the data privacy rule.
Okay, that's great. So obviously, I'm convinced that PII is critical to the system. Now, can you please elaborate? Are there any stages of securing your data?
Of course, there are different stages where we can take these measures. On the when we categorize it, there are three stages. One is when the data is at rest, when the data is moving, and the other one is when it is being used. When the data is rest, it can reside in your computer, in any storage infrastructure, any database, any file system, or it can reside in any permanent database or storage. When the data is in transit, it is actually moving from one endpoint to another, be it your private cloud or public cloud. So the moment it leaves your device, be it a mobile device or a computer, when it leaves your device and it hasn't reached to its destination, it is in transit. So you have to secure when the data is at rest and when the data is in transit. Number three is when the data is in use. So this is very critical. When you are making changes to any artifact, when you are making changes to or accessing it, or changing it or deleting it, erasing it, so at that moment you have taken out that information from the database, from its at rest position to a use position, where you are actually you may be keeping it in your RAM or in the CPU, or you're processing that data. So on all three stages, you have to have certain mechanisms, frameworks to secure your data.
I think let's just talk about a startup. Okay, and the startups start building their MVPs, and they're building the infrastructures and databases and everything. So what are some of the best practices to deal with all three different types of data flow?
Yeah, so you have to come up with the security first approach. That's for sure. Like, you have to design the system keeping security in the mind. It can't be an aftermath, okay, that you have designed the system and after that you are saying, oh, let's add that layer, let's make it secure. So you have to have that thinking when you are actually designing the system. And for the startups you mentioned, it really depends on what kind of requirement is there. So if they want to protect, if they have any sensitive information, any contracts, or for example anything that needs to be so secure that it should not be touched by even your IT admins. So for that, you need to have a different approach. But in standard, as a standard practice, what you'll be doing is you need to make sure that data in all three stages, for example, when you are when it is in transit, it should be under certain protocols. For example, TLS or HTTPS should be imposed whenever you are going to, let's say, you are going to upload a file to any server. So during this process in transit, it has to be in that pipeline that actually secures it. And it really depends that the nature of the document that is going to be uploaded, or the information. Even if you want to take a measure, even you want to go beyond that, like you don't want to rely on TLS and HTTPS, and you want to build in a mechanism that, for example, you want to encrypt it, or you want to use HMAC, or you want to scramble your data, so that once it is in the transit, even if there is a man in the middle attack, if somebody is eavesdropping, if somebody is looking at your data, they don't really get what exactly is the data. So once the data reaches to the destination, there you have to again take certain measures to encrypt the data and keep it safe. By the way, with the blessings of the public cloud that we have, they are actually providing these measures already. Like on most of the public clouds that we deal currently, AWS, Azure, GCP. So in their file system, the data at rest is encrypted with AES 256-bit, and in transit as well, it is encrypted. So what that really means is that even if somebody gets hold of the even the hard drive, so they won't be able to get anything out of it because it is encrypted.
So let's just get deeper. So let's just talk about why we're building a system which is highly secure, and obviously infrastructure comes first. So how do you sort of like build an infrastructure which is secure and safe?
That's a great question. So and as I said, we need to have that security mindset to design a system. And when we are talking about the implementation or the deployment or the actual system itself, we need to have an immutable architecture. What is an immutable architecture? That is actually you don't need to worry about, once you have deployed your servers or VMs or containers, you don't have to make changes to the system. You don't have to make changes to the individual systems, because in the immutable architecture, you have all these machines and they have like the same configuration, same image that being used. And with that, you have scalability, you have reproducibility, you have resilience, you have like integrity of the data. So all these things come into play, because imagine a situation where an attack is launched and you have like workload, let's say hundreds or 150 machines. They are running on production, they are being monitored, but one of the system, and imagine that it's not immutable and the attack gets launched. So you have to mitigate that one by one to each of the machines, right? So you have to do whatever mechanism, SSH or whatever, and you have that's called the configuration drift. So you have to make those configurations one by one. So in an immutable architecture, because you have to decommission everything, like all the workload that you have, and you have to spin up a new architecture that is spinned up using an image that has perhaps the fix to that issue. So when that architecture is there, when those machines are spinned up, you don't have to worry about the existing machines, because you're not relying on them. So everything is there. You just have to replicate it using that image, and you have to replicate it or scale it to whatever instance you want to create.
Okay, so now let's just talk about the app level. How do we protect app and make it like a real compliant and obviously security protected with PII standards?
Yeah, of course. So talking about the apps or web apps. So in apps or mobile apps, there is the security or the protection of the PII is very much important. So you have to take measures on every level. The way we are collecting the PII, the way we are processing the PII, and when we are storing the PII, how we are making calls to the API, how secure are the APIs, and how if there is a concept called zero trust architecture. So you have to have you don't have to trust anyone or anything, but you have to identify, you have to validate, authenticate every time, you have to authorize. So it's not that once you are into a system and you start trusting any hit that is coming from that IP. So the computer systems don't work the way humans do. For example, we have someone in our system, in our office, that is working from last 2 years with me, and she has recently resigned, for example, a week ago. Now I know her, I trust her, and I don't know that she has resigned and she has some bad intentions. She has come into the office and she is doing something on her machine. So my first instinct would be, I'll be trusting her. Okay, she is doing some work, but she may be stealing your information. She may be logging onto the systems, onto the server, and erasing them. So for computer systems, we have to remove this instinct, and this is already there. You have to identify, you have to authenticate, you have to check every time a request is made, that whether that's a legitimate request, whether that is there, you have to honor it or not. So that's on a very high level how you have to secure your communication, because in case of apps, they are distributed. Okay, your customers can be anywhere in the world, unlike your private cloud or your organization where your customers. It is very much distributed, so you have to have certain mechanisms, and again, there are certain services provided by public clouds that we can use to protect, to mitigate the risk, and there are certain firewalls that we can put in place, that there are certain rules that we can put in place. So the idea here is to have certain level of security measures, so that you face friction on every level. It's not that you have made a system so secure that it cannot be compromised, but what you have to do is you have to make sure that there's a friction on every level. And if your attacker or malicious outsider is going to break in, so on every stage he has to face another challenge. So that's the security in-depth mechanism that we have to have for any system.
So Tayyab, give us a strategy for CISO to protect a highly sensitive data.
Yeah, that's a great question. So you need to have in-depth security mechanism, as I mentioned, but you have to come from a security first mindset. Like you need to establish the context before you design the system. So security, you have to work on the fundamentals. You have to look at all the corners where the security can be applied or where there can be a room for any vulnerability. Number two would be you have to make your system unbreakable. So that is something that where you have to implement all those security measures or fundamentals that you have already sorted out, brainstormed. You have to apply those on all those levels. Then on third level, you have to have make the system or make disruption difficult. So you have to imagine that your system gets broken. Somebody has entered into your system. So you have to see how you can mitigate the risk, how quickly you can be in a healthy state again, how you design the system in such a way that it self heals, it protects and isolates itself. That there's a again, in the immutable architecture, you have this blessing that you can have, for example, immutable data stores. So immutable data stores, what they actually do is they create a virtual air gap. So with virtual air gap, they isolate itself from the attacker. So even if it just imagine that you have a keypad with no delete button. So when you are going to have access to the data as well, so you can't really delete that, erase that, because it is going to create copies of itself. Just like what we see in any distributed architecture or in blockchain, so where the information never gets deleted but it gets appended. So that's the idea. And then on the fourth stage, you have to reduce the downtime. You have to make the system in such a way that you have created different mechanisms. For example, you have a disaster recovery mechanism. You have any system that can be spinned up without in no time. So all of these measures can be considered when we are going to design a system.
Achha, so Tayyab, there are quite a few concepts. You talked about air gap backups, and there is this secure infrastructure, information security compliance certification, secure access to data, network security, data encryption, penetration testing. Let's just talk about those again. Mm-hmm. So look, air gap backups.
So virtual air gap. Virtual air gap is a concept that is used when we are using immutable data stores. Mm-hmm. So when we are using immutable data stores, it really means that your data store cannot be erased. Okay, any information that is there, that is going to stay there. Just an example, that you have a keypad, and you don't have a delete button in there, so your data will remain secure there. Number one. Number two, it will be isolated from your physical world. Just imagine that in the face of any cyber attack, the attacker has managed to get into your infrastructure, but the backup that you had, the reliable backup that you had, it is not even connected with your, not physically connected with your overall infrastructure. So in that case, it is completely isolated. So that's the concept called the virtual air gap.
So information security compliance and certifications, what are those? How can those be achieved? If you can talk about that.
Yeah. So we, in order to comply with certain data legislation, data protection legislation and standards such as GDPR and PCI DSS or HIPAA, so you need to have a certain compliance. Your people should be trained enough to take care of the GDPR requirements or compliance. So there are certain certifications out there that the people are trained to comply or data with. So yeah, we should be taking it seriously, and we should be hiring or having those resources who have in-depth knowledge about these compliances, and they are certified to handle that.
And what are some of the best practices for securing access to the data?
Some of the best practices of accessing the data. So you have to have you need to define rules and this again, that depends that where that data is hosted, if it is hosted on private cloud or it is hosted on public cloud. So if it is hosted on public cloud, you need to have a mechanism that no one else can access that data other than the defined services, other than the defined or whitelisted apps that can only talk to the database server. One way is this, and the other is that if we have we have this data on any file system, so that needs to be encrypted. Again, that's a blessing that come up with using the public cloud, that data at rest and data in transit both are AES 256 encrypted. So even if you have or you get hold of the hard drive or the database, so this is going to actually get you nothing because the data is scrambled. So even if you have access the database or data, then even then you can make nothing out of that.
Let's talk about data encryption.
Yeah, data encryption. So there are different techniques used to scramble the data, because we need to encrypt any sensitive information that's there. So there are different ways of encrypting the data, and there are different concepts. So let me put some clarification here. So the difference between encryption and hashing, we often hear these terms. So hashing is something that is achieved once, like you cannot reverse it. So once you have created a hash for something, you cannot make the plain text again out of that hash. Even if that hash is distributed among public, no one can actually get using that hash. No one can reverse it. It's an irreversible process. So we normally use hashing for storing passwords. Okay, so what happens is that even if it is in the database and you have got the access to the database, you won't be able to see the password. And even if you have got the access to the keys that is used to take the hash, you need to have the password itself in plain to actually produce that. So imagine you have the hash. So the only way to confirm that this hash is like for this password, you need to have that password. And encryption, on the other hand, is again, it can be decrypted as well. So if you have got some information that you want to encrypt, there's definitely a need that you want to decrypt that when you need that, when it is with its owner, when it is with authorized person. So there are certain keys that those are involved in the process that make the data encrypted, and then we can use another key in case of asymmetric keys. So you have a public key and a private key. So that's a separate topic, but there are on the main high level, on a very high level, there are symmetric encryption and asymmetric encryption. And symmetric encryption, you use the same key to encrypt and decrypt, but in asymmetric you have different keys. One is to encrypt the data and the other is to decrypt the data. Imagine you have the private key, you only know that key, and you are going to encrypt the data, but once it reaches to any authorized person, they need to have a public key to decrypt that data.
Okay, so Tayyab, let's just talk about some of the changes that has happened over the time in terms of security landscape.
It's an ever-changing field, I would say, and it would be only a fool can claim that I have designed a system that cannot be broken. So every now and then there are new attacks being launched. What we do is we normally make the data compliance. For example, we say that we are GDPR compliance, we are PCI DSS compliant, but these are just the governing rules, and these are made by governing bodies, and they come up with from a very bureaucratic processes. So I would say if you compare it with the cyber criminals, they have got much advanced way of penetrating your system, attacking your system. So you have to be always on your toes when it comes to security.
So Tayyab, have you ever worked currently in a situation where you had to protect a highly sensitive data, and maybe you're protecting it from IT admins of their own company also?
Yes, we had to work with such an organization that they wanted to secure their assets or artifacts or sensitive documents that they didn't even want their IT admins to have access to, or even if they have access to, they you can't really read it, or they wanted to protect it from any person. So yeah, we had to then design the system in such a way, and we had to mitigate, or we had to remove all those instances where there was a vulnerability that key can be compromised, or the data can be compromised. For example, it's very evident, it's pretty much like the people who work with security and encryption, they know that key store management, it's a standard practice when we have a public key and private key, and we use this any service to manage those keys. But we had to remove that part as well. So we had introduced the end-to-end encryption using zero trust architecture, and that's distributed, just like I would say, just like any blockchain system, where the security is distributed. So even if the one of the system gets compromised, you have to and you can see the data for one of the systems, even if you have got the access to the password and their secret. So you can just see their information. But even if you have entered into the system or your infrastructure, you won't really be able to see any information from rest of the users, because that impact is minimized to down to the person who's maybe secret key and password is exposed.
So can you tell me some of the building blocks that you use or architecture that we used while designing the system? Just give us some broader idea.
Yeah, so we had to use symmetric encryption. And we had to use a defense in depth mechanism. We had to, define security on multiple levels, multiple layers, where we were using combination of hashing and encryption. So, and again, it is distributed. It's not residing on any centralized digital system. It is distributed among different users. So we have designed it in such a way that you have got a security key and your username and password. Obviously, you can change your username and password, but your security key is something that remains with you, just like a blockchain system. So you often have heard that in a blockchain wallet, they give you a very long string, and you have to keep it somewhere. And if you lose that string, obviously you lose everything. So you have to have that's the con of that. But that's the that's how you design the system. If you want to have that much I would say security into the system, that you're not relying on your IT admins, you're not relying on any third party service. So you have to have that distributed architecture.
Okay, so Tayyip, thanks for answering the good question. Let's just get into some other scenarios. So I'm the owner of a big firm, and we have multiple partners, and all of those partners have access to our systems and uploading files, and so we are in a way exposed through them. So how do we protect against viruses, malwares that could potentially affect our systems through those partners?
Yeah, that's a great question, and this is the scenario that we normally face, because it's not just the organization itself. It has to interact with other clients, different other clients, and they have a shared repository where different files can be uploaded. So be it an application interface through which they are uploading the data, or it's just a shared drive. So in case of shared drive, if you are using any public cloud, so that again is something that comes with the blessing of public cloud, because they have all these mechanisms in place. If you're going to upload that any malicious file, the first thing is that they will isolate it from the rest of their clients. And number two, they will not allow uploading viruses, because they have updated virus scanners, and they can take care of that. Now, talking about the other scenario where you have developed an interface, and through an application they are actually uploading any document. So in that case, again, layer approach would be required. Some of the rules that you have to specify, for example, and that's something that we normally do, is we limit the uploading of documents to certain extensions. For example, only a document can be uploaded, or a PDF can be uploaded. So on the first level, it checks if it has the the extension that is allowed, and then they allow the access. And again, now, even if the extension is a PDF, but there can be a virus in disguise, in that case, the second layer would be where you're actually scanning your system. So that has to be an isolated system, not integrated with your infrastructure, where you actually scan that file, and if there are any viruses, you just discard it, and if it's good to go, you can allow the upload to the infrastructure. So that these are the two ways we can protect it.
So Tayyib, another scenario. So I have a startup. I built an MVP. Obviously, that's like a monolith. Okay, everything sort of like integrated, one big block, and I just moved it to cloud. Okay. So tell me, what are the next steps I need to take to have all of this PII security in place and everything?
That's what we face every time, because MVP is not designed in such a way that it can handle massive load of data. It can be scalable, or it can be resilient. So that's an ideal stage for a CISO to help the architects design it in such a way that it is secure, because you can design it from a security first mindset. So you have to break down the system into different pieces and different services. So you have to think from securing that system or that service only, that part that you have multiplied. For example, there was a monolith, and it was taking care of all of your, it's an e-commerce application, and it's taking care of your order processing, it's taking care of your I would say delivery, or all these things. Then you come up with isolating that to different chunks, different services. For example, one is handling just the order processing, and it doesn't have to worry about any other service, so just to avoid a single point of failure. So one service is down, it doesn't mean that the whole system is down. So you have to design it from that angle. And again, because it's in your hand, then the monolith will still be maybe using all those techniques where the PII is vulnerable, but your new system that is actually taking care of the PII, and it is PCI DSS compliant. So you have to shift to that system as soon as possible.
Can there be a situation I just make my monolith compliant?
Yep. So that's the question that should have been answered and considered when designing the system. But you are in the situation that you have an application up and running on production, but it's not compliant. So you need to involve the experts who have compliance, who has their certification, and they have to work with your system. Obviously, first to understand your system. What are the different touch points, data points from where the PII is being collected, and what are the measures that is being taken care. And then afterwards you can introduce security layer in there. But that is a risky thing, because again there can be a situation when that you have not um looked at, because you cannot look at all the corners when your application is up and running. Again, this is not an aftermath. You have to design the system by having a security first approach.